In 1950, four physicists who helped build the first atomic weapon sat down for lunch at the Los Alamos National Laboratory. After seeing a newspaper drawing of aliens leaving a UFO, the group began joking about extraterrestrials. Following a brief moment of thought, Enrico Fermi looked up and asked a question that has troubled science ever since. Where is everybody? Fermi's concern was rooted in the numbers. Our galaxy, the Milky Way, is roughly 13.6 billion years old. Our own sun and solar system didn't even begin to form until 5.5 billion years ago. On a cosmic scale, we are extremely late arrivals. This gap represents a multi-billion-year head start for other worlds. Even assuming interstellar travel is slow, an advanced civilization would have had more than enough time to traverse and colonize the entire Milky Way before life ever emerged on Earth. The total lack of evidence for these civilizations suggests that our failure to find life may be a result of our own anthropocentric biases, blinding us to intelligence that doesn't look exactly like our own. Our search for aliens is often a projection of human history. We assume that any intelligent species will inherently expand, conquer resources, and broadcast its presence just as we have for centuries. The dark forest hypothesis suggests a more chilling reality. In a universe where other civilizations might be predators, the only way to survive is by staying hidden, deliberately choosing silence over exposure. It's also possible that the only way to survive the discovery of world-ending technology is to evolve past aggression entirely. An advanced species might prioritize absolute peace and sustainability over the loud, visible expansion we expect. Expecting the galaxy to be filled with expanding empires is a narrow sociological assumption. Silence may simply be the most effective strategy for long-term survival. We also carry a biological bias, assuming the jump from simple cells to intelligent tool users is an inevitable outcome of evolution. Earth's own history tells a much slower story. For 3 billion years, the vast majority of the time life has existed here, our planet was populated entirely by single-celled organisms. The eukaryotic cells required to build complex life, like plants and animals, only evolved once in nearly 4 billion years. When you account for cosmic threats like gamma-ray bursts, black holes, and asteroids, the window for this rare evolutionary leap becomes incredibly small. We may be alone because we fundamentally underestimate the rarity of our own biology. Human intelligence might not be an inevitable result of time, but a freak occurrence in a sterile universe. Our technological bias is even more apparent in how we listen. For decades, projects like SETI have primarily searched for life by scanning the stars for radio waves. However, humanity has used radio for less than a century and is already moving towards lasers and fiber optics. Assuming a civilization millions of years ahead of us would still use radio technology is a major oversight. We are essentially screaming into the void in a dead language, wondering why no one is answering. To truly test if we are alone, we have to look for the evidence a civilization leaves behind just by existing, regardless of whether they are trying to communicate. We identify biosignatures by analyzing starlight passing through an exoplanet's atmosphere. Dark spectrum bands reveal chemicals like oxygen and methane. This same method spots technosignatures. Industrial pollutants like CFCs appear as synthetic markers, providing clear evidence of an advanced society. At the extreme end of engineering, we look for Dyson spheres, massive arrays of satellites built to enclose a star and harvest its energy output. We would detect these megastructures simply by watching a star dim and brighten in patterns that nature cannot produce. Shutting our human-centric assumptions transforms the cosmic silence into a new roadmap for discovery, allowing us to see the universe for what it actually is.